All right, section 2.2, we're going to talk about how to combine two statements and get what we could call a compound statement. And so the first three ways are using the word and, the word or, and then the negation, the not symbol to combine two statements. So 2.2, and, or, and then not with a negation symbol. All right, so P and Q are statements. Let P and Q be statements, which we know that means that they're sentences that either are true or false. Okay? So we can combine them to make new statements. First, P and Q. We'll talk about when is it true, when is the statement P and Q true? Yeah, if you're think about it in everyday English language, a statement, an and statement is true if P and Q both have to be true statements in order for this compound statement to be true. So P and Q in logic symbols is denoted by P and then this symbol. So when you see this symbol, you just read it, P and Q. Okay, so that's how you read the statement, P and Q. Okay? We talked about, if, remember, it's almost like the intersection, a point is in the intersection of two sets, if it's in one set and in the other set. So it's kind of analogous notation here for and. Okay? So as we said, P and Q, the statement P and Q is true exactly when both P and Q are true. Okay? So now we're going to start analyzing the truth value of a compound statement using truth tables. Okay? So a truth table is we're going to consider all the different truth values or combinations for the individual statements. Sometimes we'll have two statements like P and Q. If you have three statements, remember that some of the other common letters are P, Q, R, and S. So you can have four statements, you can have more than that, but usually for now, we'll just have probably two or three statements. When you can combine them with ands, and you want to look at all the different possible truth values for P and Q, and it depends on the truth values for P and the truth values for Q. So a truth table is used to keep track of all these different possible truth values. Okay, the truth tables, and the whole section we'll talk about this later today about truth tables. The truth tables show all possible truth values. Let's say truth value combinations for a statement. Okay, so when the more statements you have in your compound statement, truth table is going to get more complicated. I mean, the most basic truth table was like you start with the statement P, and then you list all the possible values. Well, for any given statement, it's either true or false, right? Now, if you have two statements combined, like P and Q, there's two values for P, there's two values for Q, so there's going to be four possible, 2 times 2, 4 possible combinations of true and false. And so here's how you would write the truth table for P and Q. Okay, so we're going to have a truth table with four rows in it. We'll start with P, we'll do the truth table for Q, and then we'll do the combination P and Q. Okay. Now I'm going to follow the book's notation, he uses to keep track, and so all of our truth diagrams look the same. I'm going to do the pattern that he uses with two statements. He's going to use true, true, false, false for the first column, and then alternate true, false for the second table. Okay, by organizing your truth table in this way, you'll get all the four different possibilities. Okay, you know, whether they're both true, or only P is true, or only Q is true, and then whether they're both false. Okay, so when you have two statements, you're going to need 4 rows, and I'll try to always do it this way. Which the last book I taught discrete, it was exactly the opposite. So I might catch me if I go back to that other format. Okay, so let's talk about the truth table for P and Q. We're only going to write true or false. You know, we're going to use true or false based off of the individual statements that make up the compound statement here. We're only going to write true if P is true and Q is true. There's only one row where both P and Q are both true, the first row. So I have a true, and then the rest of the 4 rows will be, the last 3 rows are all going to be false. Because here only P is true, here only Q is true, here neither of them is true, so P and Q would have this truth table. Okay, any questions so far? Okay, so truth tables are going to be very useful when we look at whether or not two statements are equivalent. Okay, you know, you might have. We'll start involving words like or and not, and then other ways to combine statements. And what we're going to look at is that we're going to look at the truth tables for two statements. If their truth tables are the same, we'll agree that that means those statements mean the same exact thing. They're equivalent. Okay, so we will use truth tables to prove that two statements mean the same thing. Okay. Any questions so far? Okay, we're going to do the same thing. We're going to talk about